Okay, so this lady walks up to the vet's office and she's carrying her pet duck with her, and the duck is not looking good. Like, it's not really moving, kind of limp. So she goes into the vet's office and she lays the duck down on the table and says, "Vet, what's wrong with my duck?" And he kind of looks it over and he uses the stethoscope and listens to the duck and looks at it and says, that's a dead duck, ma'am. I'm sorry. Your duck is gone." She's like, are you sure? Like, he's like, "Yeah, that, that duck is gone. Sorry." I said, "But you haven't even done any tests on it or anything. You just looked at it and kind of listened with your stethoscope. You didn't do anything. Are you sure? It could be just like stunned or like in a coma or something. I don't know. It's a duck. Like, maybe it's not really dead." He's like, "Fine." So he walks out of the room and he comes back and he's got this big, like, Labrador retriever dog with him. And he kind of points to the duck, and the lab, like, puts his paws up on it on the table and sniffs around the duck, and kind of looks over the duck and he's sniffing at him, and the dog looks up at the vet, kind of gives him a face, and the vet says thank you, and he tells the dog to leave, and he goes out and he comes back and he's got a cat with him this time. He kind of throws the cat on the table with the duck, and the cat's looking the duck over, kind of just looking all over and smelling the duck, and the cat looks up and kind of says, "Meow," like, "Sorry." Vet says thank you. So he leaves. The vet says, "See, I told you, ma'am, your duck has ceased to be. It is no longer of this world. I'm very sorry, but you're going to have to, accept this and move on." She says, "Okay, fine. I believe you." I don't know. Somehow the dog and the cat convinced her. So he turns around to the computer and he types some stuff out and hits print, and out comes a bill, and he hands her the bill, and it's like $2,000. And she says, "Are you kidding me? 2,000? How does this cost $2,000 for you to tell me that my duck has died, that I have a dead duck?" And he says, "Ma'am, I'm sorry. If you'd have just taken my word for it, it'd have been like $20. But you add a lab report and a CAT scan on top of that, and it's $2,000. Thank you." Dead duck, lab report, CAT scan. Nailed it. How are you doing? I know that hopefully a joke might help a little bit. A joke about a dead duck might not be quite as helpful. I don't know. But, if you didn't laugh at that, I don't know what to tell you. Although you probably didn't. Ladies and gentlemen, we are here today. We are gathered here today to say goodbye to this duck. I'm kidding. We are here today to continue our journey through Unit 4. You will notice that there is no Section 5 in the notes. So we kind of skipped Section 2 for the time being because it is a graphing calculator section, and we'll do that when you get back here in person. I have removed Section 5 completely because it's just not important. I'm sorry. It's not super like the most important. It's something that we can get rid of, and it's not that big of a deal. And that's kind of what we have to do this year. So Section 6 is what's coming up next. Now, Section 6 is mostly about graphing absolute value functions. Something we've kind of done in the past, but we've done it by just plugging numbers in and just plotting points. And so we're going to get a little bit, more clever about it today, but this is definitely a graphing section. We haven't been doing any graphing while we're at home doing e-learning. So here's what I suggest you do. If you have these notes printed out, which I know some of you do, that's great. You'll have these to use and you'll be great. I don't expect that you guys are printing all this stuff out. It's a lot to print. If you can, that's great. If not, I'm not even going to say that I would do it on your own paper because there's going to be all these graphs going on, and it's just going to be really difficult for you to do that on your own paper. What I would suggest that you do is watch the video, follow along, and then when it comes time to do your homework for this section, I would just use the completed notes that I have posted online. So just use the notes that I did already. instead of necessarily making your own. That's not the best way to go about things normally, but for this section with all the graphing, I think that's the right way to do it, unless you have this printed out, which is great. Now, as we go through here, I'm going to be explaining to you kind of what the expectations are going to be as far as kind of what you're going to be doing on your homework and stuff, okay? So first of all, though, let me get this screen shared. You all know what to do. Start rooting for it to focus. Nice. Let me get my face bigger here. And you know what? Oh, check this out, guys. Look at all of these new colored markers that I got. I felt like I was in like second grade ordering those from Amazon, although Amazon didn't exist when I was in second grade. God. Did Amazon exist when you were in second grade? The internet didn't exist when I was in second grade. All right, I'm going to put off this midlife crisis for another time. Anyways, I'm not even that old. How many times have I said that this year? I'm not that old. That's like my motto for the school year. You guys are going to like be at your class reunion 20 years from now. Like, remember Mr. Thompson always telling us that he wasn't that old? All right, anyways. So we're going to be making these graphs, and the first way that we do it is by plugging in x values and getting some y values and plotting the points, and then we're going to analyze this a little bit, and I do want to talk about this analysis. So I'm going to be plugging in these points. I'm going with purple right off the bat here. If I plug -5 in, I'm going to do this fast here because I know that you guys can plug and chug, and you don't need my help for that. So if I put -5 in here, that'll be -3. Absolute value gives me a 3, so it'll be -6 plus 5 is -1. If I plug in a -4, I'll get -4 plus 5, which is 1. If I plug in -3, I'll get 3. Plug in -2, I get 5. Plug in -1, I get 3. Plug in 0, I get 1. Plug in a 1, and I get -1. I know it's fast, but you know where those come from. All right, let's plot these points. -5, -1, -4, 1. -3, 3, -2, 5, -1, 3. There we go. We've turned the corner a little bit. 0, 1, and 1, -1. All right, I know I have a ruler on my, there it is. Okay, let's use our ruler here to make this nice and straight. And the other side. Boom, there we go. We got our nice fancy absolute value graph. So these absolute value graphs are always that V shape. Sometimes the V will be upside down like this. Sometimes the V shape will be right side up like that. Either way, the reason that absolute value stuff is included in this chapter, which has been just linear functions up until now, is because absolute value is just two lines, right, that go different directions. As far as the analysis goes, the vertex, you probably know, the vertex is that very tip of the V. Okay, and when we analyze these graphs, that's going to be one thing that we're interested in is the coordinates of the vertex. So for this one, you can see the vertex is at -2, 5. The slope of the left branch or the left piece. So if I just look at this left arm, you could call it, to get from one point to the other, I have to go up 2 and right 1. So the slope of the left arm is 2. And if I look at the other arm, the right arm, to get from one point to the other, I have to go down 2 and right 1. So down and right. So that slope is -2. You'll notice that the slopes are the same except one's positive and one's negative. That's always going to be the same. Now there's something new here which says left hand behavior, and I want to add a word to this. I'm going to call this the end behavior, and we're going to do that for the right hand too, the right hand end behavior, or left hand, left side, you can call it either one. This is kind of a new part of function analysis that we haven't really gotten into yet, so this is a good time to introduce it. The end behavior of a function describes what that function does on the very ends. That makes sense, right? So in other words, as we continue on this function left and left and left and left and left forever, what how is that function behaving? We are going to describe this end behavior using limit notation. So see, this was f of x. So I'm going to write the limit, the limit of f of x. All right, now we're doing the left side. As we move further and further left on this graph, the x coordinates of these points are getting smaller and smaller and smaller, and there is no limit to how small the x values can get. So I'm going to say as x approaches negative infinity. Okay, so what I'm saying is, as the x coordinates get infinitely small, meaning as I move further and further left on the graph, what's happening to the y values? Well, as we continue left on this graph, this function goes down, 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 and there is no limit to how low the function can go. So I would say that this limit is equal to negative infinity. In other words, as the x values get infinitely small, the y values also get infinitely small. And that's true because this graph continues left and down forever. Now let's look at the right hand, or the right side end behavior. So we'll say the limit of f of x as x approaches positive infinity. This means as I continue to go right and right and right, as the x values get bigger and bigger and bigger, and there is no limit to how big these x values can get. Well, as we continue further and further right on this graph, the function's still going down, down, and down, and so the y values are getting infinitely small. So what's to note here about this absolute value function is that the end behavior on both sides is the same, which is that the function goes to negative infinity. The y values get infinitely small. And that's going to be the same for every absolute value function, that the end behavior on either side will be the same. It'll either be negative infinity on each side, or if the graph looks like this, the y values will go to positive infinity on both sides. Okay, almost just dumped my laptop on the ground. As far as domain goes, every single number on the x-axis is represented by a point on this function. So my domain is all real numbers. Yes, the domain of every absolute value function is always all real numbers. As far as range goes, well, we already know that the y values can get infinitely small. And if we look on this graph, we see that this point here has the biggest y value of any point on the graph, and the y value of that point is 5. So that's why it's kind of helpful to know the vertex of that point, because the vertex and the range kind of go hand in hand. Now, the next 2 pages of these notes are kind of an in-class activity that we're just going to skip. I want you to notice this function, and normally I would absolutely like to do that activity and let you kind of come up with these things on your own, but desperate times call for desperate measures. I'm going to kind of walk you through how this works. See, your vertex was at -2, 5. I want you to notice that if you take the part inside the absolute value and set it equal to 0, that you get set it equal to 0, you get x equals -2, which is the x coordinate of the vertex. The +5 on the end gives you the y coordinate of the vertex. Now, folks, I would rather you think of this as a translation or a shift left 2 and up 5. If you need that to be explained a little bit more, that's okay. I'd like you to consider the graph of the parent function here. which is y equals absolute value of x, which looks like this. Okay, there's the parent function, y equals absolute value of x. Consider what you've learned about transformations. You've learned that this x plus 2 shifts to the left 2, and the plus 5 on the end goes up 5. We take this vertex and go left 2 and up 5, looky where it ends up. So when it comes to finding that vertex, I would just consider your transformations. Start at 0, 0, and then shift left, right, up, and down, and that'll tell you where your vertex is. If you want another way to find where the vertex is, take whatever's inside the absolute value, set it equal to 0, that'll give you the x coordinate. The number added to the end there will give you the y coordinate, okay? Now, some of these graphs will open up and some of them will open down. The parent function opens up. When the graph opens down, meaning it's been flipped, that is a reflection over the x-axis because of the negative out front of the function. It's a good thing we learned about those transformations. So because there's a negative out here in front of this function, we know that this one's going to be flipped upside down and it's going to open down, and that tells us the left and right end behavior is going to go to negative infinity on both sides because it's pointing down. That, along with the vertex, helps us to know the range. Now, the 2 causes a vertical stretch. Notice that on the parent graph, the right side has a slope of 1, the left side has a slope of -1. But ours has a slope of 2 and -2. That's because of that stretch. This number is going to help us find the slope of the two sides. All I'm going to do for you now is flip to this next page here, which is like 2 pages later, where we're just graphing a bunch of these things. And I'm going to graph a couple of them. And I'm going to go through, all you're going to have to do though, is you're going to have to be able to tell me all of those things that we just went through. So, you need to be able to tell me what the vertex is. You need to be able to tell me whether the graph is going to open up or open down. You should be able to tell me the slope of each side. You should be able to tell me the end behavior. You should be able to tell me the domain and the range. Okay, those are things that we can enter into Schoology where we can't enter graphs. Okay. So here we go. Vertex. Well, normally the parent function has its vertex at 0, 0. This graph is shifted left 3 and down 2. So we'll go left 3 and down 2, and that'll be the vertex of this graph. So that'll be at -3, 2. How about whether it opens up or opens down? I don't see a negative out in front of this absolute value. That means our graph's going to open up. How about the slope of each of these arms? Do you see a vertical stretch or a vertical shrink here? I don't, which means our slope is going to be 1 on the right. So we can just go up 1, right 1 on the right. And then up 1, left 1 on the other side, which creates a slope of -1. So my slopes are positive and -1. How about end behavior? The limit of f of x as x approaches -infinity. So as we go to the left on the graph, this time the graph's going up and up and up. So the left side goes to infinity. The limit of f of x as x goes to infinity. So as the x values get infinitely large, the y values are going up and up and up. So the limit is also infinity on both sides. How about the domain? The domain for absolute value functions is always all real numbers. As for the range, well, we know that the range is going to start at this point whose vertex has a y-coordinate of -2, and the rest of the graph exists above that, so the range is going to be -2 to infinity. If you don't have this graph in front of you, well, you know what the y-coordinate of the vertex is, and you know that the graph opens up, so the rest of it's going to be above that. All right, did I get everything there? Yep, I think I did, except there's one more thing that I just thought of in my head that I want to focus on as well. So I'm going to go back to this front page. And you'll remember in this one, our graph opened down, which meant that our vertex was the highest point on the whole graph. There is no point on this graph that has a y value bigger than the y-coordinate of this vertex. When that happens, we say that this point is a maximum. So I would want you to say, as part of your analysis here, that the vertex is a maximum. Because you know that the graph opens down, which means the vertex is on the very top, and so it is the maximum point. Now, if we go look at the one that we were just analyzing, sorry to flip back and forth here, on this one, the graph opens up, which means the vertex is the very lowest point on the whole graph. And when that happens, we say that that point is a minimum. So here my vertex is a minimum. Okay, let's go on and look at number 2 here. First thing I want is coordinates of the vertex. The parent function has its vertex at 0, 0, but the x minus 4 here means we're moving right 4, and the plus 5 means we're moving up 5. If we go right 4 and up 5, that puts our vertex at 4, 5. Okay, let's see what else we can know about this thing. How about whether it opens up or opens down? See that minus in the front of the function? It's going to flip the whole thing upside down. Our V shape is going to occur down here. That means this graph opens down. How about the slopes? Do you see a vertical stretch out in front here? I don't see one. That means my slopes are still positive and -1. So if I want to on my graph here, I kind of know now what this is going to look like. My point though is that it's totally possible to not have to sketch this whole graph and to still be able to analyze it, because you just get a general idea of what the graph looks like. Let's try end behavior. The limit of f of x as x approaches -infinity. Meaning, as I proceed to the left on the graph, well, it's going down, so the limit would be -infinity. The y values get infinitely small. It's the same on the other side. The limit of f of x as x goes to +infinity. Again, on the other side, also going down. So that limit is -infinity as well. How about the domain and the range? Domain is always all real numbers. For the range, I know that the graph opens down. I know that the vertex is a maximum because it's on the very top. So my range, the y-coordinate of the vertex is going to be the maximum value of the range. So 5 is the maximum value in the range. The range is negative infinity to 5. Okay? On the next video, we're just going to be continuing more of analyzing these absolute value graphs, but I know that if I do that now, this video is going to be far too long. In fact, it might be when we get back in person that we do that. I don't know. We'll see. Have a good day. Sorry about the dead duck earlier, but hopefully it made you laugh. It's getting close to being able to see you back in here in person. I'm excited.